49 light-years from Earth, a discovery has changed everything we know about worlds beyond our solar system. Astronomers have confirmed something extraordinary, an atmosphere around a rocky planet in the habitable zone of its star. This is LHS 1140b, and it may be our best chance yet to find a second Earth. LHS 1140b orbits a small red dwarf star called LHS 1140, located in the constellation Cetus, the sea monster. The planet was first discovered in 2017 by the M-Earth project, a ground-based survey searching for planets around the smallest and coolest stars in our galaxy. But back then, astronomers only knew it existed. They had no idea what lay beneath its clouds. The planet itself is a super-Earth, about 5.6 times the mass of our own world and roughly 70% larger in radius. For years, scientists debated its nature. Was it a dense rocky world like Earth? A mini-Neptune with a thick hydrogen atmosphere? Or something else entirely? The debate raged on in scientific journals and conference halls around the world. The answer came in July 2026, when a team of astronomers using ground-based telescopes detected the unmistakable signature of an atmosphere. The data revealed a helium-dominated upper atmosphere surrounding LHS 1140b. This is the first confirmed atmosphere around a relatively rocky planet in the habitable zone of any star. It is a milestone that astronomers have been chasing for more than 2 decades, ever since the first exoplanet was discovered. What makes this discovery so breathtaking is what it implies about the planet itself. Refined measurements of its mass and radius revealed a density much lower than a purely rocky world. The numbers tell a compelling story: between 9 and 19% of the planet's mass is likely water. LHS 1140b is not just a rocky world. It is an ocean world. Imagine a planet completely covered in water, with oceans hundreds of kilometers deep. No continents. No mountains. No dry land at all. Just a global ocean stretching from pole to pole, under a thin atmosphere that astronomers have now confirmed exists. This is not science fiction. This is real. This is happening right now, 49 light-years away, in a star system that we can actually observe. The planet orbits within the conservative habitable zone of its star, receiving about 43% of the incident flux that Earth gets from the Sun. That puts it in the perfect region where liquid water can exist on its surface. Not too hot, not too cold. Just right. The habitable zone is often called the Goldilocks zone, and LHS 1140b sits squarely within it. LHS 1140b transits its parent star, meaning it passes directly in front of it from our perspective on Earth. This is crucial because it allows astronomers to study the planet's atmosphere in detail. When the planet transits, starlight filters through its atmosphere, imprinted with the chemical fingerprints of the gases present there. This technique is called transmission spectroscopy, and it is the most powerful tool we have for studying distant worlds. The detection of helium in the upper atmosphere is just the beginning. Astronomers are now racing to observe LHS 1140b with the James Webb Space Telescope. JWST has the power to detect water vapor, methane, carbon dioxide, and even potential biosignatures in the planet's atmosphere. The observations are scheduled and the world is waiting. Every second of JWST time is precious, and this planet is at the top of the priority list. This discovery marks a turning point in the search for life beyond Earth. For decades, we have wondered if any rocky planet in the habitable zone of another star could hold an atmosphere. Now we have proof. LHS 1140b shows us that atmospheres can survive around planets orbiting red dwarf stars, despite the intense stellar flares these stars are known for. Red dwarfs are the most common type of star in the Milky Way, accounting for about 75% of all stars. If planets around them can hold on to their atmospheres, the number of potentially habitable worlds in our galaxy skyrockets into the billions. This single discovery has multiplied the number of places where life could exist by a factor of 10 or more. The ocean world of LHS 1140b also raises profound questions. If the planet is covered in water, could life exist there? On Earth, life began in the oceans. Microbial life thrives in extreme underwater environments, around hydrothermal vents, in complete darkness, under immense pressure. If LHS 1140b has geothermal activity on its ocean floor, the conditions for life could absolutely be met. Of course, there are challenges. The planet orbits a red dwarf, which means it is likely tidally locked, one side always facing its star, the other in perpetual darkness. The day side would be bathed in constant starlight, while the night side would be frozen solid. But in between, along the terminator zone where day meets night, temperatures could be just right for life. This band of eternal twilight could be the most hospitable region on the planet. The ocean itself would be unlike anything in our solar system. With no land to break the surface, the global ocean would be shaped entirely by the planet's rotation and the star's gravity. Massive tidal waves could circle the planet continuously. The atmosphere, rich in helium and likely water vapor, would create a greenhouse effect that keeps the planet warm enough for liquid water over most of its surface. The discovery of LHS 1140b's atmosphere also validates the methods astronomers have been developing for decades. Transit spectroscopy, the technique used to detect its atmosphere, was first proposed in the early 2000s. It took over 20 years of refinement, better telescopes, and patient observation to reach this milestone. Every exoplanet detection before this was leading up to this moment. What comes next is even more exciting. With JWST, astronomers will be able to construct a detailed profile of the planet's atmospheric composition. They will look for water vapor, which would confirm the ocean hypothesis. They will search for gases that could indicate biological activity. They will measure the planet's temperature and weather patterns. Each new observation will peel back another layer of mystery. LHS 1140b is only 49 light-years away. In cosmic terms, that is our backyard. Future telescopes, like the planned Habitable Worlds Observatory, could directly image the planet and study its surface. Someday, we might even send a probe, though that would take centuries with current technology. But the dream of reaching another world is what drives exploration forward. The wider significance of this discovery cannot be overstated. For the first time in human history, we have confirmed an atmosphere on a potentially habitable, rocky world beyond our solar system. This is not just a scientific achievement. It is a philosophical one. It changes how we see our place in the universe. Every star in the night sky could host planets like LHS 1140b. Every one of those planets could have oceans, atmospheres, and perhaps even life. The Milky Way contains at least 100 billion stars. If even a fraction of them have planets in the habitable zone, the number of potential ocean worlds is staggering, possibly in the hundreds of millions or even billions. Let us also consider the star itself. LHS 1140 is an M-dwarf, a red dwarf star with only about 1/5 the mass of the Sun and a much cooler surface temperature. These stars are known for their long lifespans, often trillions of years, far longer than the Sun will live. This means that any life that arises on LHS 1140b would have an almost unimaginably long time to evolve and develop. But red dwarfs also have a dark side. They are prone to powerful flares that can strip away a planet's atmosphere. The fact that LHS 1140b has retained its atmosphere despite these flares is a hopeful sign. It suggests that the planet's magnetic field is strong enough to protect its atmosphere, or that the atmosphere is being constantly replenished by volcanic activity on the ocean floor. The composition of the atmosphere itself is a tantalizing mystery. Helium is not a gas we typically associate with habitable planets. On Earth, helium is rare and light, escaping into space. But on LHS 1140b, the helium could be a sign of a much more complex atmosphere below. The planet likely has a thick layer of water vapor, nitrogen, and possibly oxygen, hidden beneath the helium-dominated upper layer. This stratified atmosphere would be fascinating to study. The upper layer, rich in helium, would give the planet a hazy, glowing appearance. Below it, clouds of water vapor would swirl around the global ocean. Storms could rage across the planet's surface, driven by the constant energy from the red dwarf star. LHS 1140b is also a reminder of how far we have come. In 1995, the first exoplanet was discovered orbiting a Sun-like star. 20 years later, we were detecting thousands of them. Now, in 2026, we are analyzing their atmospheres. The pace of discovery is accelerating, and the next decade will bring even more revelations. The quest to find life beyond Earth has entered a new phase. We are no longer just looking for planets. We are studying them. We are measuring their atmospheres. We are mapping their potential for life. LHS 1140b is the vanguard of this new era of exploration. The implications for astrobiology are profound. If LHS 1140b turns out to be a true ocean world with a stable atmosphere, it becomes the most promising target in the search for extraterrestrial life. Every future space telescope mission will prioritize this planet. Every theoretical model of exoplanet habitability will be tested against it. Consider the timescale of this discovery. The planet was first detected in 2017. It took 9 years of observations, data analysis, and technological advancement to confirm its atmosphere. In astronomy, patience is not just a virtue. It is a requirement. The rewards of that patience are now being realized. The technology that made this possible is remarkable. Ground-based telescopes equipped with advanced spectrographs can now detect the chemical composition of an atmosphere 49 light-years away. The precision required is staggering. We are measuring the dimming of a star by less than 1%, and from that data, extracting the fingerprints of gases in a planet's atmosphere. For now, LHS 1140b stands as a beacon of hope in the search for other Earths. It is proof that the conditions for life as we know it exist elsewhere in the cosmos. The ocean world is waiting. And humanity is just beginning to explore its shores. The universe has never felt so close.